Hello everyone, in this video we're going to explore the work rate and distance time work problems. Alright, we have the general rate, it's going to be quantity divided by time. We have the speed, it's going to be distance divided by time. We have the work rate, it's going to be rooms painted divided by number of hours. And the last one, units price, it's going to be total cost divided by number of items. Alright, we're going to move on to the first one, work rate, work problems. To find the total time it takes for two people to complete a job together, such as painting rooms, you can use the combined work formula, which is total time equals total work divided by combined rate. So how do we find the total work and combined rate? We're going to let capital R represent total number of rooms or total units of work. Now we'll let the little r represent time it takes person 1 to complete one room. Then you have the rate for the person 1 to complete it to be 1 over A. Similarly, let B represent the time it takes the person 2 to complete one room. Then the rate for the person 2 is 1 over B. Then you need to find the combined rate by adding 1 over A and 1 over B. Finally, you're going to calculate the total time. It's going to be capital R, which is total number of rooms, divided by little r, which is the combined rate. Alright, let's take a look at the first example. Mary is painting the rooms for her new house. Before she moves in, it takes her about 4 hours to paint one room. So this one is A, right? Her friend Kelvin is going to help, and it takes him about 3.5 hours to paint one room. This one is B, right? So from right here, you can calculate the rate for Mary to complete the work is going to be 1 over A, right? The rate for Kelvin to complete the work is going to be 1 over B, right? So 1 over A, which is 1 over 4. This is 1 over 3.5, right? Then we're going to multiply the top and bottom by 2. So it's going to be 2 over 7, right? Now her house has 8 rooms. This one is the capital R, right? So how long will it take them to finish painting, which is capital T equals how much, right? The rate for Mary to complete the work is 1 over 4, right? And the rate for Kevin to complete the work is 2 over 7, right? Then you have a combined rate, which is you're going to add 1 over 4 and 2 over 7. Now we need to find the LCD of 4 and 7, which is 28, right? So you're going to multiply the top and bottom of the first fraction by 7, right? So it's going to be 7 over 28. Multiply the top and bottom of the second fraction by 4. You're going to have 8 over 28, right? So it's going to be 7 plus 8 is going to be 15 over 28, right? Now you need to find the total time it takes them to finish painting. Is capital T equals capital R divided by little r, right? Capital R is 8 rooms right here, divided by 15 over 28, right? And it's going to be the same thing as 8 multiplied by reciprocal, this one, which is 28 over 15, right? So it's going to be 224 over 15 hours, right? This one is the final answer. Now let's move on to the next one, distance time work problems. When moving in a medium like water, canoes, boats, or airplane or train that has its own movement. When you move against the current, in other words, you're going to move upstream or into the wind. In order to calculate the effective speed, you're going to take the object speed, subtract the current speed. you slow down because you are fighting the resistance. Now, when you move with the current or downstream or with the wind, the effective speed equals object speed plus the current speed. You speed up because you are getting a push. Now, you know that the distance equals speed multiplied by time. Now let P be the speed of the object in still water or air. Let C be the speed of the current or wind. Let D be the distance traveled one way. Now you're gonna create a table like this. This one upstream, this one downstream, this one speed, time, and distance. Now when you move upstream, you're gonna go against the current, right? So the actual speed equals the speed of the object subtract the speed of the current, which is P minus C, right? When you move downstream, it's going to be P plus C, right? Now we have the time to move upstream is T upstream. The time to move downstream is T downstream, right? Now the distance equals speed multiplied by time, which is this guy times this guy, this guy times this guy, right? Then finally, you just set this guy equal this guy, right? Because they have the same distance, right? Now let's move on to example number 2. Mark and his brother David are fighting over a top airplane while playing in their yard. Mark grabs the plane and takes off, running at a rate 7.5 miles per hour. 1 minute after, Mark starts running. David starts to chase him at a rate 9 per hour. How long will it take David to reach Mark, and how far will they have run? Mark's speed is 7.5 miles per hour. David's speed is 9 miles per hour. Right here, right? Let T be the time Mark runs, right? Then look at this one right here. 1 minute after Mark starts running, David starts to chase him, right? So it means Mark gives David 1 minute, right? You need to convert 1 minute to hours because you look at the speed right here, 9 miles per hour, 7.5 miles per hour, right? So 1 minute, which means 1 over 60 hours, right? Now, since Mark gives David 1 over 60 hours, which means the times for David to run is T minus 1 over 60, right? Now, the distance equals speed multiplied by times, right? And this one, 9 times T minus 1 over 60, right? Now, we just let this guy and this guy equals, and we solve for T, right? Now we just distribute this one, so we have 7.5 T equals 9 T minus 9 over 60, right? Now we're going to simplify 9 over 60, divide the top bottom by 3. So we have 3 over 20, right? Whenever you solve the linear equation with fraction, we're going to multiply both sides by the denominator, which is 20 right here, right? So I'm going to multiply both sides by 20. 20 times 7.5 is going to be 150 T, right? Equals 20 times 9 T is going to be 180 T, right? 20 and 20 cancel out, it's going to be negative 3, right? Subtract 180 T both sides, so we have negative 30 T equals negative 3, right? Divide both sides by negative 30, so T equals 1 over 10, right? Now we need to answer the question, how long will it take David to reach Mark, right? So we substitute over here, right? Because we need to calculate the time for David to run, right? So it could be 1 over 10 subtract 1 over 60, right? the LCD is 60, right? So we're going to multiply the top bottom of the first fraction by 6. So it will be 6 over 60 subtract 1 over 60. And 6 subtract 1 is going to be 5 over 60, right? Now we're going to simplify this one. It's going to be 1 over 12 hours, right? Now, if you want to convert this one into minutes, you just multiply by 60, right? So 1 over 12 multiplied by 60, which is 5 minutes, right? How far will they have run, right? So we substitute 1 over 10 back to one of the two right here to solve for the distance, right? So the distance is 7.5 times 1 over 10, right? And it's going to be 0.75 miles, right? Now let's move on to question 3. Heather rows a boat upstream, then turns around and rows back downstream to her starting point. It takes her 5 total minutes to do this, right? So the total of times is going to be 5 minutes, right? And we look at the speed right here, it's going to be meters per second. And then we need to convert 5 minutes into second, right? So 5 minutes multiplied by 60, right? So it could be 300 seconds, right? And this one is the total times, right? Now let's T be the time Heather rows upstream, right? And downstream should be 300 subtract T, right? Remember, the current is moving at a rate 3 meters per second, and Heather can paddle at a rate 7 meters per second, right? So upstream, you need to subtract the current speed, right? So it could be 7 minus 3 equals 4, right? And downstream, you're going to add the current speed. So 7 plus 3 is going to be 10. We're going to use these two numbers right here. So keep that in mind, right? Now the distance, 4 times t, right? 10 times 300 minus t, right? Now we just let this one equal this one and we solve for t, right? Distribute this one, so we have 4t equals 3000. Subtract 10t, right? Now we're going to add 10t both sides, so we have 14t equals 3000, right? Divide both sides by 14, so we have t equals 3000 divided by 14. Divide the top bottom by 2, so we have 1500 divided by 7. Now we need to answer the question, how far down the river did she go before turning around? So down the figure, which is upstream right here, right? So you have 4 times 1500 divided by 7, right? So it will be 6000 divided by 7 meters, right? And times right here. Now let's move on to example number 4. You're on a plane right northbound into the wind and it takes 4 hours to fly to its destination. The flight home with the wind takes 3 hours and 18 minutes. The wind speed is 40 miles per hour. What is the speed of the plane without any wind? Alright. So we don't know the speed of the plane. We call this ask. Now, when you fly against wind, the actual speed should be ask minus 40, right? Because the wind speed is 40 miles per hour, right? With the wind, it's going to be ask plus 40, right? Now, the times you fly against the wind is going to be 4 hours, right? The time you fly with the wind is going to be 3 hours and 18 minutes. You need to convert 3 hours and 18 minutes into hours. So it could be 3 hours plus 18 divided by 60 hours, right? So it could be 3 hours plus divide the top bottom by 6. It could be 3 over 10, right? So it could be 3, 3, 10, or 33 over 10 hours, right? So we put 33 over 10 hours right here. Now the distance is going to be s minus 40 multiplied by 4, right? And this one s plus 40 multiplied by 33 over 10, right? Now we just let this one equals this one, right? Now we're going to multiply both sides by 10 to eliminate the denominator. So it's going to be 40 times s minus 40 equals 33 times s plus 40, right? Now we just distribute this one. So it could be 40 s minus 1600 equals 33s plus 1320, right? Subtract 33s both sides, so we have 40s subtract 33s, and you're going to add 1600 both sides, so it could be 1600 plus 1320, right? So it's going to be 7s equals 2920, right? Divide both sides by 7, so s equals 2920 divided by 7 miles per hour. And this one is the final answer. Now let's move on to number 5. You're on the boat that goes 91 miles downstream in 7 hours, but requires 12 hours to go 84 miles upstream. What is the speed of the boat in still water? And what is the speed of the current? So I'm going to call the speed of the boat in still water B, right? And I'm going to call the speed of the current B, C, right? I just use the first letter right here, right? So you see that if the boat goes upstream, you have B minus C, right? And the boat goes downstream, you have B plus C, right? With current, right? Now the time you have 7 hours goes downstream, right? And upstream we have 12 hours, right? Now the distance upstream is going to be 84 miles, and downstream is going to be 91, right? So you have a system of two equations. The first one, the speed multiplied by the time equals 84, which is B minus C multiplied by 12 equals 84, right? The second equation, B plus C times 7 equals 91, right? Now, to solve the system of two equations right here, we just divide the first equation both sides by 12. So we have B minus C equals 7, right? Divide both sides of the second equation by 7. So we have B plus C equals 13, right? Now to solve the system of two equations right here, we're going to use elimination method, right? We just add them up. B plus B is going to be 2B. Negative C plus C is going to be 0 equals 7 plus 13 is going to be 20. Divide both sides by 2, so you have B equals 10, right? Now, to solve for C, we substitute 10 for B back to this equation right here, or this equation right here, either works, right? So I have 10 plus C equals 13. Subtract 10 both sides, so C equals 3, right? And this one is the current speed. And this one is the boat speed. Now I have the practice for you, problem number 1, and I leave the keys over here for you to check. Number 2 right here. number 3 right here, and number 4 right here. And it's your time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.